Go so smoothly, but I'm here now. So first of all, I'm presenting the executive presentation that would have been given by my supervisor, Dr. Lapas, who unfortunately couldn't make it because he came down with an illness. So I'm just going to give 2 or 3 background slides about where I'm from and what we do there. So I'm currently a research assistant and PhD student at the Surrey Space Centre at the University of Surrey. So that's a picture of what it looks like. So most of you know about Surrey Satellite Technology, which is the commercial spin-off company that was started by the university in 1985, and that's since been acquired by ACT-Surrey. And this partnership with SSTL, the Space Centre, the academic side, and ASTREM gives us the synergy and exploitation potential. So there's a lot going on at the University of Surrey at the Surrey Space Centre. We're working on cutting edge technology. We're basically doing research and development for SSTL, and yeah, it's a great environment, and there's lots of opportunities. There's 10 odd academic staff at the Surrey Space Centre, a couple of research assistants like myself, and then also tons of PhD students. At the Space Centre we've got quite good facilities to develop space components and to test. So among them we've got air bearing tables, we've got 3 vacuum chambers now, 1 big one and 2 smaller ones. The bigger ones only brought into commission recently. And then we're working on a couple of CubeSat missions. There's a full ground station at the Surrey Space Centre where we've got tracking VHF, UHF antennas and an S-band dish. And that's linked up to the GENSO network of ground stations. Then there's also work going on UAVs, robots, there's an optics lab, RF lab, and so forth. So within the Surrey Space Centre, each academic has got his own focus group. So Dr. Lapas, his group is called the Space Vehicle Control Group. So these are just the people that answers to him. So the research activities being performed in this group would then include attitude control and determination, and also electric propulsion, and then more esoteric concepts like solar sails, drag sails. And we get funding from all over. So one of the funding grants that we've recently been awarded is a FP7 contract for a project called the Hybridsail. And that's a flight demonstration of 5x5 meter solar sail. But one of the objectives also is to demonstrate drag deorbiting using this sail. So this is a continuation of a project that started 2 years ago called CubeSail, which is also a solar sail mission. The difference between moving from CubeSail to the Hybridsail would be the fact that we've now got a bunch of partners willing to help us out. So we've got DLR there to help us manufacture booms. We've got lots of people with materials experience, attitude control experience, and so forth. Then we're also working on something called Hybridsail, which is an inflatable sail concept to do away with all the extra mass that you have with the rigid structure. So this would use a cool gas generator to inflate the sail, and we're looking for opportunities to develop that further as well. And now this is really why I'm here today. So just a quick summary of what I'm going to present later on with the full presentation. Hybridsail is a proposal that we put in for this, and it's a study to look at a combination of tethers and sail for deorbiting. So use drag force that the sail gives you to deorbit, and use the force that you can achieve with the charged tether to help out with this deorbiting. So, and I'll present later on that the added advantage is that we can increase the altitude that we can deorbit from with the tethers than compared to what we can achieve with just the sail by itself. So the mission concept would involve packing all of this into a nano satellite sized box, putting that up there with thruster propulsion capabilities, docked with a piece of debris that's been selected for deorbiting. And then detumble this potentially uncooperative piece of debris using magnetic actuators. After that, we will deploy the sail and tethers, and the deorbiting phase will start. So the actual contents that I will be presenting later, I'll look at a bit of orbit analysis to show you the deorbit times that we can achieve under various test conditions, like with tethers, without tethers, with the sail, without the sail, different parameters, different orbits, and so forth. I'm going to talk a little bit about the satellite concept design, so how would the satellite be built and how would the docking system work, all up to conceptual level. And then finally look at one or two attitude control strategies for this. So that's everything.
Okay, well that was 10 minutes short, and we are almost back in time, even if the schedule is completely disrupted.